All right, let's just jump right in. Forget everything you think you know about space exploration. Seriously, we're not talking about planting flags anymore. We are living through what might just be the largest industrial revolution in human history, and it's all happening just a few hundred miles straight up. Here it is. This is the number that has Wall Street, Silicon Valley, and entire governments completely obsessed. By 2035, the global space economy is projected to hit $1.8 trillion. And to put that in perspective for you, that growth rate is absolutely crushing global GDP. So this isn't just another new market, it's becoming a new center of gravity for the world's economy. And this quote? It just nails the sheer scale of what's happening. We're finally moving past thinking of space as just the place for a few astronauts to visit. We're starting to see it for what it actually is, a brand new container for human activity with a resource base that is, well, for all intents and purposes, basically infinite. So you gotta ask, right? How did this happen? How did we go from this niche, government-run thing to a trillion-dollar commercial frontier in what feels like the blink of an eye? Well, it turns out there's a single key that unlocked the whole thing. And in this explainer, we're gonna show you exactly what that is. Okay, so to really wrap your head around that $1.8 trillion number, you have to get the new economic architecture that's being built in orbit right now. It's kind of like a building with two main pillars holding everything up. So here are those two pillars. First, you've got the backbone. Think of this as all the heavy lifting, the rockets, the satellites, the actual hardware. That's already a $330 billion industry. But the real explosion in value, where more than 60% of all the new growth is going to come from, is what we call the reach. This is where space tech becomes totally invisible and just part of our daily lives. Think about GPS. It's a space technology that runs everything from the stock market to the map on your phone. See, the future isn't just about building stuff in space. It's about what space can do for all of us down here on Earth. And all of it, the backbone, the reach, that entire trillion-dollar opportunity, it's only possible because of one single, absolutely game-changing event: the radical collapse in the cost to just get to space in the first place. You know, for decades, we were all paying this brutal gravity tax. To get a single kilogram into orbit on the space shuttle, it cost a jaw-dropping $54,500. Then, everything changed. SpaceX's Falcon 9 came along with its reusable booster and just slashed that price by 20 times. But look at what's next. The target for Starship, we're talking about a potential cost of maybe $10 to $100 per kilogram. That's not just an improvement. It's a fundamental break from the entire history of transportation. I mean, just look at this chart. The visual of this cost collapse is just insane. Whenever the price of transportation drops this fast, civilization expands. It happened with ships, it happened with railroads, and now it's happening in space. At $100 a kilo, business ideas that were total science fiction, like manufacturing in orbit or space-based solar power, suddenly become not just possible, but maybe even a no-brainer. And look, this whole revolution isn't just a one-company show. For a market to be healthy, you need real competition. And now we have this amazing group of rivals all trying to get a piece of the action. You've got Blue Origin going head-to-head with SpaceX on heavy-lift rockets. Rocket Lab is getting really good at deploying constellations of satellites. Relativity Space is literally 3D printing entire rockets. And then you have wild ideas like Spin Launch, which is trying to just fling things into orbit. This competition, this is the best sign we have that the space economy is really here to stay. So now that we've basically broken the chains of that old gravity tax, the big question changes. It's not about how we get to space anymore. It's about what we can actually do up there. So, welcome to the Made in Space era. Here's a mind-blowing example of what's now possible. On Earth, gravity creates these teeny tiny little flaws in certain materials. But in space, that problem just goes away. Take this stuff called ZBLN optical fiber. When you make it in microgravity, it's so flawless that it has up to 100 times less signal loss than the fiber that connects our world today. We're talking about something that could make the global internet unimaginably faster. But the implications for medicine are maybe even more incredible. In zero-G, you can 3D print complex human tissues and even organs without them collapsing under their own weight. This isn't just a science experiment. This is the start of an industry where one day hearts and livers could be grown to order in orbit for patients on Earth. I mean, think about it. We could potentially end the organ transplant list forever. And this stuff is already happening.
right now. The pharmaceutical giant Merck is using the International Space Station to grow purer crystals for its cancer drug, Keytruda. Why? Because these better crystals let them create a super concentrated version of the drug. So instead of a long, drawn-out IV infusion, a patient can just get a simple shot. That is a direct improvement in someone's quality of life, made possible by going to space.
And this brings us to the long-term vision, the real endgame. It's this idea called ISRU, which is basically a fancy way of saying living off the land. Instead of hauling everything up from Earth at great expense, we start using the resources we find in space. We could mine water ice from the moon's craters and crack it into hydrogen and oxygen for rocket fuel. We could use metals from asteroids to build new stations. This is how you create a truly self-sustaining, permanent human civilization beyond Earth. But of course, no gold rush in history has ever been clean and simple. This incredible new opportunity has kicked off a very high-stakes scramble for resources and control, and it comes with some huge risks and, yep, rising geopolitical tensions. And you can already see a clear divide forming. On one side, you have the US-led Artemis Accords, which is a coalition that's all about commercial development and creating safety zones for companies on the moon. And on the other side, you've got the China and Russia-led ILRS, which is basically a competing bloc building its own base with its own rules. And what are they all racing for? They're racing for the moon's south pole because that's where the water ice is, the strategic resource that could become the gas station for the entire solar system. Then you have this terrifying threat, and it's from our own garbage. It's called the Kessler syndrome. Basically, the idea is that if we get too much junk in orbit, one collision could create a cloud of debris, which then hits another satellite, creating even more debris, setting off a runaway chain reaction. Before you know it, low Earth orbit becomes a permanent, impassable wall of shrapnel traveling at 17,000 miles per hour, slamming the door to space shut for centuries. And the risks don't stop there. Space is now officially considered a war-fighting domain by major world powers, all of whom are developing weapons that can take out satellites. Meanwhile, back here on Earth, the sheer number of launches is raising some serious environmental questions, since all that black carbon from rocket exhaust could potentially harm the ozone layer. These are not small problems. They have to be managed carefully. So, with all these risks, you might be asking, why? Why are we doing all this? Why this massive, expensive, dangerous push out into the cosmos? Well, the answer goes way beyond just economics. It really gets to the core of our long-term survival as a species. You see, almost every single astronaut who has seen the Earth from a distance reports this profound mental shift. It's called the overview effect. From up there, national borders just vanish. You see Earth for what it is, this single, beautiful, fragile boat in the dark. As more and more people get to experience that change in perspective could have huge positive impacts on how we treat each other and our planet. But at the end of the day, the ultimate driver is this. Living on only one planet makes us incredibly fragile. One really bad asteroid strike, one supervolcano, one global catastrophe, and it's game over. Becoming a multiplanetary species isn't just about adventure. It's a survival imperative. It is quite literally creating a backup drive for all of life on Earth. It's our species insurance policy against extinction. So, this $1.8 trillion opportunity, it's here, and it's real. It promises solutions to some of our biggest problems and a real shot at long-term survival. But it also demands a new level of wisdom and cooperation, so we don't just export our old conflicts and bad habits into this final frontier. The opportunity is absolutely immense, but so is the responsibility. The stars are waiting for us. The only question left is, are we ready?